So here's the deal. There's an accelerometer inside your iPhone or iPod Touch, and it detects your device's position and movement, which is why it can figure out which way up you're holding the iPhone and whether you're moving or shaking the thing. So let's get some core ideas down first before jumping into the code of how to use it. There are 3 accelerometers inside the iPhone, one for each of 3 axes. You've got the x-axis running left to right, the y going up and down, and the z-axis going back to front. Now, all of these cover positive and negative values ranging from -1 to +1. In your classic iPhone pose, with the device held upright, there is negative force being applied on the y-axis, the force of gravity, which is pulling down against the iPhone. So the y-axis here would be a -1. But there's nothing directly affecting the x and z axes, as the iPhone isn't being tilted either side to side, x, or back to front on the z. Now, these are very idealized approximations. They're never perfectly 0 or 1. They're just somewhere in that range. What you might think of as perfectly upright could be considered causing a small force on the x and z axis. So let's show a couple of examples. If we tilted this to the left, what would happen is you'd be having a negative force being pulled down against the x-axis, so x goes to -1. It's neither tilted forward or backward, so z is 0. And in this case, y would be 0 as well, because there's now not a negative force being pulled on the y-axis. As the x-axis ranges from -1 when it's tilted to the left to +1 when it's tilted to the right, if we somehow took it to a kind of half and half position, you'd have a little more force being applied on the x-axis, so it might be 0.5, 0.6, 0.7, and a little less force being done to the y because it's not pulling straight down against the y, so y wouldn't be -1, it might be -0.5 or 0.6. And if you took the iPhone from its classic upright position with y at -1 and leaned it back, you'd have a bit more force being applied, a negative force on the z-axis and a smaller negative force on the y-axis. And a temporary movement in a particular direction can also affect these values, such as moving the iPhone down suddenly will force the y-axis into perhaps a positive value, because what's happening is the gravitational force pulling down on it will be minimized or possibly even reversed to a positive force, and returning to a standard negative value once it returns to rest. Now, you really don't need to try and remember which combination is which. It's not something to commit to memory. Just understand that the combination of these 3 axes and their values allows you to know both position and movement. Now, really, as a developer, you have 4 things you can do with this whole idea about changing position of the iPhone and reacting to that change. 1, detect orientation changes. Switching portrait to landscape, whether that's right or left, is the classic example, though the iPhone itself can actually tell you if it's face down, face up, or even upside down, although these are limited in their value and they aren't often used, so portrait to landscape, either landscape left or landscape right, is the classic example. You could detect and react to a shake. This is used by some applications as a way of interacting with it, but it's also becoming used quite commonly as a gesture for undo. You could go all the way and use all the different values of the accelerometer actually used for control in your application, tilting and moving the screen. Again, because both position and movement in space can be measured, this is quite commonly used in games and entertainment apps for controlling some icon or some sprite on the screen. And of course, you can ignore it. This is also very, very common. And what we're going to do is concentrate on the first 3, as I'm pretty sure you can ignore it already. So we're going to see how to support switching views and support the shake and even get to the internal accelerometer data.